Hello and welcome to Controllers Tech. This is the 11th video in the ESP32 series using the Espressif IDE, and today we will continue with the small series covering the SPI displays in ESP32. In the previous video we saw how to connect the display, how to configure it, and how to draw a bitmap on it. Today we will see how to implement the LVGL graphic library to our project. I am going to continue with the project I created in the previous video, so please watch that video if you haven't. I am not going to discuss the basic interfacing part, rather we will focus on implementing the LVGL. We will also see how to load the UI, created using the Squareline Studio, into our project. Let's open the LVGL documentation to see if there is any porting guide for ESP32. Here under the chip vendors we have ESP32, NXP, ST32 etc. Let's open the guide for ESP32. As you can see here, there is not enough information on porting this library. Although if you check the STM32 guide, there are steps mentioned in details. For ESP32 they have mentioned that the simplest way to integrate it is by using the ESP LVGL port. I tried using this port, but it is complicated compared to the one which we will use in this tutorial. As I mentioned, I am going to continue with the project created in the previous video. Here is the project, I have named it Part 2, but it is the same. We will use the same component method, which we used in the previous video to include the LCD library. So open the component registry page again. Here you can see the LVGL component, let's open it. Here you can select the library version you want to use, I will go with the latest 9.2.2. Let's download this archive, and unzip it. Now copy this LVGL folder inside our component folder, which we created in the previous video. This folder is used to store the components we will use in this project, and LVGL is one of them. Now open the IDF component.yml file, and add the LVGL dependency to this file. You can copy the dependency from the LVGL page itself. Here we are using the version 9.2.2. Alright, let's build the project once to check for errors. There are no errors, so let's proceed ahead. Let's delete this hello file as we do not need it anymore. Instead include the LVGL header file. Inside the main function, delete these functions and leave only the display initialization. I have prepared one template file, which includes all the functions we need to port LVGL. I will leave the link to this template file in the description of this video. This file has two sections. Let's copy the upper section, and paste it outside the main function. Let me put an indication here, which says the LVGL starts from here. Let's go back to the template file. Now copy the second half of this file, and paste it inside the main function, but leave the display initialization at the beginning. We need to do some inclusion now. Let's include syslock header file, parameter header file, and ESP timer header file. The timer file is for the ESP timer we are creating here. Let's build the project once. Alright, all the errors are gone now, let's understand the LVGL implementation. After initializing the display in the main function, we will call the function LVInit, to initialize the LVGL library. You can see all the necessary steps required to add LVGL to your project in the documentation itself. As mentioned here, we need to first initialize the library, then initialize the drivers, connect the TIC interface, display interface, and any input device interface, and then call the timer handler every few milliseconds to manage the LVGL timers. So after initializing the LVGL library, we create a LVGL display. Then create buffers to store the pixel data. I am using 2 buffers. LVGL can draw into one buffer, while the content of the other buffer is sent to the display in the background. This way, the rendering and refreshing of the display become parallel operations. Also note that the buffer size is set for 20 lines. This function will initialize the above buffer, and here we are using the partial frame buffer strategy. Next we will associate the LCD panel handle with our LVGL display. This way the LCD driver will be connected to the LVGL display driver. Next, set the color format of the display. ILI9341 uses RGB565. In fact, most of the SPI-based displays use the same format. Next we will set the flush callback. This callback will be used to copy the pixel data into the display area. This callback function is already defined outside the main function. Here you can see, inside this callback first of all we call another function, port update callback. This port update callback is responsible for setting the rotation of the display. As I mentioned in the previous video, we use the combination of the swap and mirror functions to rotate the display. After setting the rotation, the flush callback will swap the RGB byte order to fix the endianness. And finally it will call the draw function to draw the color data into the provided area. After setting the callback function, I am also setting the rotation to 180 degrees. After initializing the display driver, we need to connect the TIC interface. To do this, we will first create an ESP timer. The function LVGL TIC is the callback function for this timer, and it is defined outside the main function. After creating the timer, we will start it to run periodically. Inside the timer callback, we will tell the LVGL about how much time has elapsed. After setting up the timer, we will also define a callback for the flush ready notification. This callback will basically call the LVGL flush ready function. The purpose is to inform the LVGL that the color data is ready to be flushed on the display. The LVGL will then call the flush function to send the data to the display. All the initialization is complete now, so we will create a demo UI for the display. But before doing that, we must acquire the mutex as the LVGL is not thread safe. The UI I am calling here is a very basic one. It just prints hello world on the center of the display. Finally we need to manage the LVGL timer handle, so we create a task with a bigger stack size. This task will keep calling the timer handler function, so the LVGL can function properly. Alright, that is all. Let's flash this project to the board. You can see hello world is printed on the display. We can also manage the LVGL configuration from the SDK configuration of the IDE itself. Here you can see the option for LVGL configuration. You can manage the configuration based on which things you need for the project. For example, I want a bigger font size, so I am changing the default font size to 20. Let me uncheck the 14 here. Let's build and flash the project again. You can see the size of the string has been increased with this change. So we are able to successfully implement the LVGL library with our project. Now we will see how to create a UI with Squareline Studio, and then implement the UI in our project. Let's open the Squareline Studio. There are already many examples provided here, but we will use them later, after implementing the touch functionality. Click on Create, and choose the LVGL version. Earlier we downloaded the version 9.2.2, so we need to use the same version in the studio also. Click on the Eclipse for PC. Now let's configure the project. Choose the folder where you want to store the project files. Set the resolution of the display here. I don't want to rotate the display, The shape is rectangle, but the color depth is 16-bit for the RGB 565. Click on Create to create the project. Here you can see the basic layout for the studio. On the left side we have different widgets, controllers, visualizers, etc. I want to display an image, so let's choose this widget. On the right side you can see all the properties related to the image. We can modify them as per our requirement. First of all we need to add the image into Assets. I already have an image of the same resolution as the display. The image is in the PNG format. Here you can see the image has been copied into the Assets. Now under the Image Properties, select the image from the Assets. And now the image has been loaded to the screen. Let's also put one spinner at the top of this image. Again we can change the properties of this spinner. For example, I am changing the arc color to red. Once the project is ready, open the project settings. Here we need to add the path, where the UI files will be exported. Inside the project folder itself, I am creating a new folder named UI. This is where the files will export to. Also you can put LVGL.h in the LVGL path. Click Apply Change to save this configuration. Now go to Export, and click Export UI Files. The UI files will export to the UI folder we created. Here you can see the folder has been populated with different files. We need all these files in our project. So let's copy this entire folder inside our main folder. We still need to add the libraries manually. So open the CMake list inside the UI folder, and copy all the source files. Now open the CMake list of the main folder. Paste the copied source files here in front of the main.c. Here the files will not be directly accessible, so we need to include the folder path in front of them. Also include the UI directory here. That is all, let's build the project once. Alright, we do not have any errors, so let's proceed. Inside the main file, include the UI header file. And finally inside the main function, we will call UI to initialize the UI. That is all, let's build and flash the project to the board. You can see the UI has been loaded on the display, but the colors are not accurate. Actually the color order in the ESP LCD configuration is set to RGB, let me change it to BGR. As I mentioned in the previous video, you can change the color order if you see some discrepancy in the color. Let's build and flash the project again. You can see the LCD is now displaying accurate colors. The spinner is also rotating just as we designed in the studio. So we are able to interface the LVGL with the ESP32 using the ESP IDE. We also saw how to use the Squareline Studio to design the UI, and then how to use the UI in our project. We will implement the touch functionality in the next video of this series. Later we will design a more sophisticated UI, which will include some touch events too. This is it for the video. You can download the project from the link in the description. Leave comments in case of any doubt. Keep watching, and have a nice day ahead.